Okay, you kind of have two choices how to set up the variables for this problem. Here's one way, but it leads to more complicated derivatives and functions. But if you let x equal the distance from the base of the ladder, which is right here, to the wall, which is 8 feet high right here, then the distance from the base of the ladder to the building is 2 more than that, because this distance is 2. And these are similar triangles, the little triangle on the left and the big triangle. So it's true that 8 is to x as y is to x plus 2, where y is where the ladder is going to actually touch the building. And of course, it has to go just over the top of the wall. And so if this is y, 8 times the quantity x plus 2 all over x, then by the Pythagorean theorem, L squared equals x plus 2 squared plus blah, blah, blah. But it turns out it's quite a bit easier if we set it up this way. Let x equal the distance from the base of the ladder here all the way to the building. Since this distance is 2, this distance is x minus 2. The wall is still 8 feet high. But now when we set up the proportion from the similar right triangles, y is to x as 8 is to x minus 2. Solve for y. There's an expression for y right there. So by the Pythagorean theorem, L squared equals x squared plus y squared, but y is 8x over x minus 2. Note that x has to be greater than 2 because we have the base of the ladder can't be inside the wall. We can take the derivative if you want implicitly. So 2L times the derivative of L with respect to x equals 2x plus, use the power rule, and then followed by the chain rule. The derivative of the inside requires the quotient rule, and that gives you this expression right here. So that's 2x plus 2 times 8x is 16x. This numerator over here simplifies to minus 16 because the 8x's cancel out. And so there is 2x minus 256x over x minus 2, the quantity cubed. If we divide that by 2L, we've got a formula for the derivative of L with respect to x. Then we want to know, when does that equal 0? And the truth is, it only equals 0 when the numerator equals 0. So that's the equation you want to solve. Here it is. When does that equal 0? Well, you might notice when I went from here to here, I divided both sides by 2x. Normally, you can't do that because you could be dividing by 0. But since we know x is greater than 2, it's okay to divide both sides by 2x. So x minus 2, the quantity cubed, equals 128. Take the cube root of both sides and then drag the negative 2 over, and there is the value of x that generates the minimum ladder length. Now, you could go through different tests to prove that L of that number achieves a minimum, second derivative test, or some other things, but we'll just leave that as an assumption. So here's L of x, the length of the ladder depending on x. And if I put in this value, I get 13.207, rounded to the nearest thousandth. Okay. There you go. I hope that helped. If you have any questions, post a comment.